How do quadratic equation roots apply in real life? Imagine you're throwing a ball into the air. Have you ever wondered exactly when it will hit the ground or how high it will go? That's where quadratic equations and their roots come into play. Roots are the solutions to the quadratic equation, which tell us the specific points where the equation equals 0. In real life, these roots help us find important moments like when an object reaches a certain height or when a business breaks even. A quadratic equation looks like this. A times x squared plus b times x plus c equals 0. The roots are the values of that make this true. These roots can be real numbers or complex numbers, but in many practical situations, we focus on real roots because they representing actual quantities like time or distance. Let's look at how roots are used in everyday situations. When you throw a ball, its path follows a curved shape called a parabola. The roots of the quadratic equation describe the exact times when the ball leaves your hand and when it lands back on the ground. Engineers use this to calculate how far the ball will travel or how high it will go. This is important in sports, designing amusement park rides, or even in firefighting when aiming water streams. In business, quadratic equations help model profit or loss based on the number of products sold or the price set. The roots show the points where profit is 0, meaning no gain or loss. Between these points, the business makes a profit. By finding these roots, companies can decide the best number of items to sell or the ideal price to charge to maximize earnings. Quadratic equations also assist in construction and design. For example, if a park wants to add a pathway around a circular area, the dimensions can be described with a quadratic. The roots tell us how wide the pathway should be to reach a specific total area. In physics, when objects fall under gravity, their height over time can be modeled with a quadratic equation. The roots indicate when the object hits the ground. This helps in calculating how long it takes for something to fall from a certain height. Structures like suspension bridges or arches are shaped with curves called parabolas. The roots in these cases help engineers find where the structure touches the ground or other points, ensuring safety and stability. So, in all these examples, roots of quadratic equations give us exact points in time or space where something important happens. They help us predict outcomes, plan designs, and understand how things change. Learning how to find and interpret these roots makes algebra not just a subject in class but a tool we use every day to solve real problems.